Okay, so this is your second assignment for the day. This will be your periodic tables and lab ideas. And so we're taking what we understand from the periodic table and our observations from the lab, and we're going to try to make sense of it as we proceed forward and getting ready to do nomenclature and electron configuration. So I'm first breaking off the document that you guys will be downloading before I go to my app to work through some things. And you're going to find hyperlinks that I have placed in here for pretty much, I think, every single topic. And that's in case you have questions, or maybe I can't quite make it over to where you're at, and this way you can have some extra support. So, like, for example, where it says Part A, if you click on that, it's going to take you out to this YouTube video here, and you'll play it, and it goes over Valence Electrons. And so just a little extra support as you go through this worksheet and as we go through this new material. So I'm going to go over here to my app. And I'm just going to remind you that you should label this on your periodic table as well. But generally, whatever the group number is, that's the valence electrons that it will have. So example, group 8 will have 8 valence electrons. Okay, and not this 18. So like group 3 will have 3 valence electrons. And so it's your responsibility to get the rest of that filled in, and make sure you label your periodic table with that information as well. And then the next part has group ionic charges. And again, there's a great video that goes over it as well. But the general rule is that my metals will be cations, and a great way to remember how to tell the difference between this is that T becomes a positive charge. And that also just means that we lose electrons easily. So groups 1, 2, and 3 are going to lose electrons. It will also be your metals as well. And that's why you've got to know where your stair-step line is located at, because that gives you your division. And we're going to find that along the stair-step line, we have others that are in groups that also are cations as well. So again, we go back to that stair-step line. So, and then the other type is that we have our non-metals, and those will be anions. And these are negative charge. So these gain electrons, and we're always focused on the outside electrons, which means we're focusing on valence electrons. And the reason we focus on those is because these are the ones that are responsible for bonding. The interior electrons, and what I mean by that, if I'm looking over here at this row here, let's just pick on sodium. So I won't pick on sodium here. Sodium has 1 valence electron, but in total it has 11 electrons. Well, those 10 electrons that are in rows 1 and 2 are shielded. And what does that mean that they're on that? Well, if I was going to draw this, and I'm just going to quickly draw this and say, here I have sodium, which I've got 11 protons in there and 12 neutrons. So I can call it sodium, or I can go in there and go, okay, I got 11 protons and 12 neutrons. If you're wondering where I got this number from, again, 11 protons. This rounds up to 23. 23 minus 11 gives me 12 neutrons. Okay. And it's on row 3, which means if I'm drawing my rings, which we're getting into, then I'm going to have ring 1, ring 2, and ring 3. Now, when I look at row 1, I've only got 2 boxes, hydrogen and helium, and so there's 2 electrons hanging out on that ring. I'm just going to draw them real quick. So we got this one, we got this one, and those are obviously clearly larger than what they actually are. Okay, but let's just get a point across here. So that's row 1. And then I go down to row 2, and I count my boxes, and I go 1, 2, 3, 4, 5, 6, 7, 8. I got 8 boxes. So I'm going to have 8 electrons spaced out here. And there's a reason why that I have them spread out like this, and I have them doubled up. There's actually a rule. Well, those electrons there, these are what we call our shielded electrons and are not available for bonding, okay? But these on the outside, which sodium only happens to have 1, is available for bonding, and that is what we're interested in. So that's my valence electron. So that is why this is important to know what the valence electron count is. Again, so groups 1, 2, and 3 are going to lose electrons, which means I have a +1 charge, +2 charge, and a +3 charge. I'm going to skip group 4, but group 5, I'm trying to get to 8, so 5 minus 8 gives me a -3. And then 6 minus 8 gives me -2. And 7 minus 8 gives me a -1. And for this final group here, it's 0. These are inert. Okay, or a full octet, which means, because oct means 8, we have 8 valence electrons. Okay, so that's what that means. And so make sure you mark that up on your periodic table as well. And then we have formulas. And so I took common formulas we had in our lab, and I'm asking you to look at them and look at the formulas, look at the name, and explain why the formulas are written as they are. So here I have sodium, and I have a periodic table on here for a reason. So I want you to look at, where is sodium? Okay, so here's sodium. Here's chlorine. Why do I get sodium chloride in this formula for it? Okay. Here is barium. Here's chlorine. Why do I get BaCl2 when I'm writing barium chloride? Here is potassium. Here is chlorine. I get KCl. And the last one we'll do, here is aluminum. Here is sulfur. I get aluminum sulfide. I want you to explain me why. Look at that logically and see if you can deduce what's going on. And again, that there is a hyperlink there for a video. Then we have types of bonds, because you've been messing with stuff that's ionic and covalent, and so you've been looking at bonds without even realizing you're looking at bonds. And so again, I have my periodic table. I have it marked with your metals and non-metals as well. There is a video again up here if you want to look at it. And so I want you to write down lithium. Lithium's over here, and that's a metal. So we're going to call that a metal. Chlorine is over here. That's coded as non-metal. I want you to go through there and write out their metal and non-metal. And then I want you to watch this video and deduce what an ionic bond is, a covalent bond, and a metallic bond is. And then we have these questions. And these questions go with the video that is right here. And it's going to go through step by step on these questions, and I want you to answer the questions as you go through it.